The insane engineering of SpaceX Starship. Elon Musk invented Starship, a totally reusable two-stage orbit super-heavy lift-launch vehicle, to achieve its objective of making the human race an interplanetary species. With its cutting-edge spacecraft designs, SpaceX always has advanced humanity, and the company continues to soar to new heights every year. Welcome to yet another amazing video of incredible tech. If you have any queries related to technology, don't forget to visit our channel. SpaceX recently completed the first test flight of its futuristic Starship rocket, which Elon Musk plans to use to send humans to Mars and land astronauts on the Moon. Without its Raptor engines, the Starship wouldn't be able to escape the gravitational pull of Earth and travel between planets. The Starship's engines must provide an enormous amount of thrust because it can lift objects weighing up to 100 tons. This is important because the spacecraft will deliver all of the necessities for life to the planet if Musk's goal of putting people on Mars is accomplished. The very heavy rocket will lift off with the spaceship atop it. Combined, it is referred to as a Starship. With its nose cone and landing fins, the entire thing will be 120 meters, 394 feet tall. The spaceship is undoubtedly a tribute to the rocket ship of classic sci-fi films and comic books. SpaceX built 6 Raptor engines over a 10-year period and is located in the back of the craft. The engine's design decreases the amount of propellant lost in the middle of the combustion, which occurs in phases. It possesses propellant tanks that supply methalox, a mixture of liquid oxygen and liquid methane to the Raptors. Although methane is not a typical fuel for rocket engines, it may produce a significant amount of thrust and is functional. The Sabatier reaction, a chemical reaction, can produce liquid methane from atmospheric carbon dioxide and underground water on Mars. On Mars, the rocket can be refueled for the return journey, bringing the planet much closer to independence. The enormous rocket weighs 6.8 million pounds of chilled methanol and has a height of 70 meters, 230 feet. This guy will be powered by 28 Raptor engines generating 16 million pounds of thrust. As the engine itself develops, Raptor 2 is currently undergoing intensive testing at SpaceX's McGregor test facility. Raptor 1 already had 185 tons of thrust. This is increased to 230 tons by the Raptor 2. Additionally, Raptor 2 has undergone significant simplification, and Musk claimed that the thrust has increased while the price has decreased. The maximum thrust of R2 is now 247 tons. So, according to SpaceX, 250 tons will be achieved, which is certainly necessary for SS to operate. Less wiring and plumbing were located around the engine in the Raptor V1 and V2, which had notable cosmetic differences. The turbopump looks to have shrunk, and the tubing has gotten more compact despite being visible throughout the engine. The Raptor II SN5 appears to be a Raptor boost engine, which means it is unable to steer or gimbal and cannot throttle as low as the Raptor's main engine. Compared to V1, this engine offers a significant improvement. Everything was redone, including the electronics, a chambered nozzle, and term equipment. This made it possible for items to be moved and compacted as the turbopumps got stronger. His dislike of flanges has led to the conversion of many into welds. According to Musk, flanges are challenging at high pressures and cryogenic temperatures. Welding from flanges at pressures of 700 to 800 bar and 11,000 psi is advantageous. Musk also stated that the individual burner controllers have already been moved to individual boxes rather than being distributed throughout the engine. This allows for further advancements to the point where the Raptor no longer requires a shroud, reducing its mass and trying to make it a pain in the rear. According to Musk, the engine will be flame-proof, and the elimination of shrouds might well reduce its size, allowing it to function at 330 bar in the main chamber without overshooting pre-burner pressure. This will reduce pressure loss and ease bottlenecks. Testing is going well at SpaceX McGregor. The engine's functionality was demonstrated during the presentation. The ultimate goal is to keep the engine chamber from liquefying. The Raptor engine's exhaust travels at more than 10 times the sound speed. Moreover, the fuel in the chamber burns at high enough temperatures to damage the chamber's walls. If you're beginning to wonder why the wall does not really melt, it's because the gas flow is expertly managed to maintain the flame away from the walls as a precaution. Through the walls, supercold gasoline is injected. Similar to the engines of other rockets, the Raptor engine breathes out gases quickly enough to propel the spacecraft forward. On the other hand, the Raptor is a powerful rocket that was made possible by creative engineering. SpaceX's engines use a full-flow staged combustion cycle. in contrast to traditional rocket architecture. The engine's dual-redundant spark pluglet torch igniters control ignition, doing away with the requirement for a separate Merlin-specific consumable igniter fluid. The Raptor fully mixes oxygen and cold methane. SpaceX is well on its way to certifying Raptor for the first ever orbital launches of Starships. The Starship Super Heavy launcher is supposed to shut down and separate from the spacecraft 10 seconds short of 3 minutes after launch. To reach orbital velocity, the spaceship will then run 3 to 6 Raptor engines for less than 6 minutes. Interestingly, despite the fact that the Starship is approaching orbital velocity, the same timetable does not mention the orbital burn necessary for the first orbital test flight. The maximum liftoff thrust is a super heavy rocket with 33 almost identical engines will be around 7,600 tons. This translates into a thrust-to-weight ratio that is higher than 1.5. The thrust-to-weight ratio is incredibly respectable for a large rocket using liquid propulsion alone, which enhances launch pad acceleration and reduces gravity losses. Also revealed were the hexagonal heat shield titles that will protect the Starship vehicle as it re-enters the Earth's atmosphere. The hottest sections of the tile survived multiple temperatures of 2,510 degrees Fahrenheit or 1,777 degrees Celsius at times during the test. Hexagons are in excellent shape for something like this because there is no straight path for hot gas to accelerate through the gaps. Soon, transpirational cooling will indeed be added wherever there is erosion in the shield. This suit of armor should allow the Starship to be prepared for launch just about immediately after landing, with little to no refurbishment required. The fact that they were able to pull this off demonstrates their engineering genius. The other materials have not been discarded. The heat shields are only there to protect the Starship vehicle as it re-enters the atmosphere, not the rockets as a whole. The heat shield is not intended for use with the Super Heavy booster, which is still constructed of stainless steel. SpaceX is reusing Falcon rocket boosters made of aluminium, lithium, and carbon fiber. Starship rockets are extremely expensive given that they are typically single-use. They burn through their fuel in a matter of minutes and splash down into terrestrial oceans, having placed their payload on the proper trajectory. It is wasteful, not to mention insane, that we throw some of the best examples of human engineering and expensive materials into the ocean. But for the longest time, it was the only way to get them into SpaceX. Their success is a huge step forward in spacecraft engineering. If one rocket can be made reusable, massive savings and expenses can be made, ultimately reducing the cost of interstellar travel for us. For the time being at least, that is a long-term goal. So instead of dumping the main equipment into the ocean as the rocket re-enters, the parts will be recovered and the rocket will just be refurbished and refueled before being relaunched for another mission. In terms of fueling, SpaceX has already devised a method to refuel the rocket mid-flight, as space, as we all know, is severely lacking in gas stations. The tanker Starship variant's sole purpose is to refuel other spacecraft in orbit or flight around the Earth. Once refueled, this one will actually perform a deorbit burn and fall back through the atmosphere to land on the planet's surface. The payload compartment, located at the front of the ship, is where humans or cargo will be placed. When this part reaches space, it will detach from the structure, causing the Super Heavy rocket to flip over and come back to Earth. It would then deploy its own grid fins from the sides to help it gently land back on the launch pad, ready to launch again. If we're going to put 1 million people on Mars, we'll need enough space and facilities to keep them entertained during the journey. The Crew Starship variant has a cabin of 1,000 cubic meters that can accommodate 100 passengers. The ship will have a common area that will include lecture halls, cinemas, and restaurants. So what do you think about this technology? Do you want to know more about Starships? Let us know in the comment section below.